equation. Glory, can you tell us what's wrong with this equation and how we would have made it better? Kakwezi, Glory. Come on, save time. People who don't
Yes.
answer you. Yes, hurry up.
I beg your pardon?
What's wrong with this equation? It was number 1 in our assignment. How many people failed it? And I was asking, what was wrong? There is something I said you should do about this equation.
Should be balanced.
It should be balanced, yeah? Yes, this equation is not balanced. The way it appears in the notes, I told you that it was not balanced. And we are supposed to balance it. Surprisingly, many of you presented it just like that. Yeah? That was wrong. So, Glory, how can you balance this equation?
Oh, we put a 2 in front of sodium chloride
Oh,
and
so we need a 2 here on sodium chloride. Eh? We needed a 2 here, and when you put a 2 there, the sodium, you put 2 to balance chlorine, because here the chlorine atoms are 2. So you put 2 on sodium chloride to balance chlorine, but when you put 2, the sodium atoms will now become 2. So what you have to do, you also have to come to where there is this sodium atom, and you also put a 2 behind here. I think you understand what I'm saying. So many of you presented this equation when it was not balanced. Check your work and make it better. Again, the same case should apply to potassium chloride here. It is also not balanced. You need to put a 2 on potassium chloride, and you need also to put a 2 on potassium. When you put a 2 on potassium chloride, you'll have balanced chlorine, but potassium atoms are going to become 2, so you also need to put a 2 here. So, like we said, balancing equations should be part of you. Then the second equation that was required to be completed was this one, potassium plus sulfuric acid. Where did many of you fail? You failed on the formula of potassium sulfate. The valencies of radicals, they should always be with you all the time. The valence of the sulfate radical is 2, and the valence of potassium is 1. So this is the correct formula of potassium sulfate. Please, you people make correction. That's the correct formula of potassium sulfate. Now, the potassium atoms here become 2, so you will need to put 2 on potassium, and that was the 2 that was required there. Another question, if I remember very well, was asking you to state what is observed when magnesium is burned in oxygen, or when magnesium reacts with oxygen. My friends, I'm still repeating. When a question asks you to state what is observed when a substance is burnt in oxygen, please give the color of the flame and the color of the substance that is formed at the end. When magnesium burns in oxygen, it burns with a brilliant white flame. A brilliant white flame or a bright white flame forming A white
A
solid,
white solid.
white ash. Come on, how many times are you going to fail that question? Eh? This is one of the commonest questions on Earth, on the chemistry planet. Eh? And the white ash or the white solid is magnesium oxide. So when magnesium burns in oxygen, it forms magnesium oxide, and it is the one which is white ash or white solid. And the color of to balance, we need a 2 on magnesium oxide, and we also need a, when we put, we begin by making oxygen even number. That's what I told you. So when you put 2 to make oxygen atoms 2, the magnesium atoms will become 2. So you must put a 2 on magnesium to balance it. The same thing applies to calcium. But for calcium, it burns with a bright orange flame. So magnesium, white flame. Calcium, orange flame. And the product in all is white ash. Now, there was another question, and this is very important, that magnesium burns in nitrogen. Just to remind you, when magnesium burns in nitrogen, the product is magnesium nitride. This is magnesium nitride. Magnesium what? Nitride. And the valence of magnesium is 3. No, the valence of magnesium is 2, and the valence of nitrogen is 3. So when they exchange valences, the magnesium atoms become 3, and nitrogen atoms become 2. So that's the formula of magnesium nitride. To balance, just put 3 on magnesium. But the question was asking you to state what is observed when this magnesium nitride is dissolved in water, and you give an equation. I said when magnesium nitride is dissolved in water, it will give out an alkaline gas. And I don't know if you remember very well, I told you that there is only one alkaline gas in O-level chemistry. Who can tell us the name of that alkaline gas? Only one alkaline gas in chemistry.
Ammonia.
Ammonia. Good. So when magnesium nitride is dissolved in water, the product is ammonia gas and nitrogen and magnesium hydroxide. When magnesium nitride is dissolved in water, the product is ammonia gas and magnesium hydroxide. So how do you state the observation? Whenever there is a gas in a solution, don't think twice. The observation will be bubbles of a colorless gas. I want us to understand that whenever there is a gas and there is a solution, aqueous solution, for example, water, and the gas is evolved in water, that gas will always appear in the form of bubbles or effervescence. So the observation I wanted there was bubbles of a colorless gas and a colorless solution. The colorless solution is magnesium hydroxide, and the bubbles are due to formation of ammonia gas. It was 1 mark, so each of these 2 half mark. Colorless solution, magnesium hydroxide, then bubbles of a colorless gas for ammonia. I remember telling you this equation is not very easy to balance. So when you are balancing, what did I tell you? Who remembers very well the first thing you do when you are balancing? Bridget, you were there, you remember. What is the first thing you do when you are balancing this equation? Yes, Shadrach.
We begin by making oxygen an even number.
That's not what I said. I said, no, you know, there are some equations which are not easy to balance, and I told you some of those equations you should always learn where to start from. For example, this equation, to balance it with ease, very fast, put 6 on water. That's what I said. Put 6 on water. Don't begin by putting 2 or what, put 6 on water. When you put 6 on water, or alternatively, the magnesium atoms here are 3. Yeah? So, and the other side, on the right hand side, that means you must put 3 on magnesium. And when you put 3, the oxygen atoms become 6 now. I think you can see that. 3 times 2, that becomes 6. And you have to put 6 on water. Put 6 on water. Then nitrogen atoms, there are 2. So you put 2 on ammonia. Ammonia, its formula is NH3. Yes. So the observations were colorless solution and bubbles of a colorless gas. Now, the other question was asking you that beryllium, magnesium, and calcium, they are elements in group 2. So the question was, which one of them does not react with water? Which of those elements does not react with water under any conditions? Baguma. Baguma. Is Baguma here? I told you those people I call and they don't answer, you'll be removing you. Baguma, I know you are here. Organic element does not react with water. Beryllium, magnesium, and calcium. Which one does not react with water?
Beryllium.
Is beryllium. That's good. That's correct. And which one reacts with cold water?
Calcium.
Calcium, that's correct. And which one does not react readily with cold water, but reacts with steam?
Magnesium.
Very good. The answer is magnesium. Please keep that chemistry in your head if you want to be successful in Senior 4, in UNEB. Those are the questions we usually tell you, but you don't take our information serious. 60% of your questions in UNEB are going to come from Senior 1 and Senior 2. Now, I ask you to write equations. Beryllium does not react with water. Why do you write the equation? There is no reaction that will take place, so you cannot write an equation there. Then calcium reacts with cold water, so you write the equation between calcium and cold water. The products are calcium hydroxide, and it gives out hydrogen gas. Okay, then you put 2 on water to balance. Now the problem usually comes from here, but I'm happy that this time you got it. We are saying magnesium does not react readily with water. If it reacts with cold water, the reaction is very slow. I told my class that it will even take 2 weeks for you to get hydrogen gas. But with steam, the reaction is very rapid and very fast. So the state of water must always be steam. So magnesium plus water, the products are magnesium oxide plus hydrogen gas. That equation does not even need you to balance it. It will balance itself. So even if there are 2 2's here, when you divide it out by 2, you will still get the same thing. The observations. Who remembers the observations that I told you in senior, okay, that I told you when you were at school? Observations. You can tell us what is observed when steam is passed over heated magnesium. Someone? What do you observe when steam is passed over heated magnesium?
It burns with a bright white flame, forming a white solid.
It catches fire and burns with a bright white flame, forming a white solid. So that is it for the corrections. Let us now go to halogens, and today we shall be able to finish chemical families. No, let us try and see if we can finish them. Chemical families, and this time we are looking at halogens. Halogens, these are elements which are in group 7. So halogens are group 7 elements, and they include chlorine, there is bromine, there is iodine, and fluorine. Now, among all these, the first element in the group is fluorine, because it has 2 energy levels, so it is in period 3. Okay, it has 2 energy levels, so it is in period 2. Then it is followed by chlorine, bromine, and iodine. Now, sometimes we ask for the characteristics of these elements of group 7. Characteristic number 1 is they exist as diatomic molecules. They exist as diatomic molecules. What do I mean? When you are writing a formula of chlorine, you write it as CL2. When you write a formula of chlorine, you write it as CL2. Meaning, for chlorine molecule, it is Cl2. That's why we are saying they exist as diatomic molecules. It is very hard for chlorine to exist as an atom itself. You know, molecules, we said they cannot exist by themselves. So chlorine, this is chlorine atom, but chlorine molecule, it is Cl2. So characteristic of those elements, number 1, they exist as diatomic molecules because they are usually gases. And all gases exist as diatomic what? Molecules. Now, the reason is here. This is because they lack 1 electron to completely fill the outermost energy level. Hence, their atoms share electrons in order to completely fill the outermost energy level. Shadrach?
So what of ammonia?
Hmm?
How comes ammonia is not diatomic?
because ammonia is formed by a combination of two atoms. Yeah? When a gas is formed by a combination of two atoms, then you follow the rule of exchange of valencies. So ammonia, it is formed by nitrogen and hydrogen. It is a combination of two independent atoms. But for chlorine or oxygen or nitrogen or any other gas, it is only one atom, atoms of the same kind. Eh? Oxygen, there are two atoms. Chlorine, it is one atom. You get that? So the atoms are of only one type of atoms. But ammonia, it is formed from nitrogen. It is an independent element. It is an independent element. Then hydrogen is also an independent element. So ammonia, nitrogen has a valence of 3 and hydrogen has a valence of 1. So they exchange the valences. In other words, ammonia is a compound. Yeah? Ammonia is a what? A compound. And compound, when a compound is formed, you must show the exchange of valencies. Combining power. Then chlorine, oxygen, what? They are molecules of atoms of one. They are molecules of atoms of one type. Eh? They are of one type of atoms. I think you are answered. So these gases, these group 7 elements, they exist as diatomic molecules because they lack one electron in the outermost energy level to get 8 or to become stable. For example, if you are to write the electronic configuration of chlorine, be it there aside in your books, its atomic number is 17. So its electronic configuration is 2 to 8 to 7, meaning chlorine is only lacking one electron to become stable, or to have 8 electrons in the outermost what? Energy level. And that's what we are trying to explain here. This is because they lack one electron to completely fill their outermost energy level. Hence, their atoms share electrons in order to completely fill the outermost energy level. So two chlorine atoms can share electrons to form a covalent bond between two chlorine atoms, such that each of the outermost energy levels now has 8 what? Now has 8 electrons. These elements, they react by gaining one electron. Yes, to become stable. That's how they react. For example, if you are to write a compound between sodium and chlorine, sodium donates one electron, and that one electron is gained by chlorine. So this is what the equation is trying to say. Chlorine plus an electron, you form a chloride ion. You know, after gaining an electron, the charge is negative. When an atom gains electrons, it gets a negative charge. Physical properties. All group 7 elements are colored. Chlorine is greenish yellow. That's the characteristic color of chlorine. Then fluorine is pale yellow. Bromine is brown volatile liquid. And iodine is a shiny black solid. I think we have ever seen iodine when we are looking at sublimation. Physical property number 2. Down the group, physical state changes from gas to liquid and to solid. For example, fluorine can only exist as a gas. Chlorine can only exist as a gas. Chlorine can exist as a gas. Then it can also exist as a liquid. By the way, chlorine can also exist as a liquid because it is the one that we usually have in jig. Jig and water guard treatment of water. So chlorine can exist as a liquid. But bromine can also exist as a liquid, and it can also exist as a gas. But iodine can exist as a solid. That's why we are saying down the group, the state changes from gas to solid to liquid, and finally to what? Solid. Fluorine and chlorine are gases at room temperature. Bromine is a liquid, and iodine is a what? A solid. That is very important for us to note. But we are continuing to say that shiner black iodine solid is sublime into purple vapor on slight heating. I think we remember that iodine sublimes on heating. They have low melting and boiling points. That one we shall look at it more in bonding. Let us look at chemical properties of these group 7 elements. Now, like any other elements, the reactivity decreases. No. This should be the reactivity increases down the group. For group 7 elements, the reactivity decreases down the group. Okay, yeah, it is okay. The activity decreases down the group, i.e. fluorine is the most reactive, and iodine is the least reactive. That one is okay. Fluorine is the least reactive. No, fluorine is the most reactive, and iodine is the least reactive. This is because these elements react by gaining electrons, and down the group, the atomic radius increases. So we don't need to go in details of atomic radius. That one we shall look at it in senior 5. But for now, let us keep in our mind that down the group for non-metals, but for metals, the activity increases down the group. For example, in group 1, potassium is the lowest down the group and it is the most reactive. But for non-metals, as you go down the group, the reactivity, as you go down the group, the reactivity decreases. So in group 7, we shall lay emphasis, or we shall look mostly at chlorine. We shall look at the chemistry of chlorine. Even later on in senior 3, we shall be able to look at chlorine and its compounds, only chemistry of chlorine. Reaction with water. All halogens dissolve in water, forming a mixture of acids. And when we look at chlorine independently, when chlorine dissolves in water, it forms 2 acids. One acid is hydrochloric acid. Hydrochloric acid is this one, and the other acid is hypochloric acid. This is hypochloric acid. That is its formula. Hypochlorous acid is this, and then this is hydrochloric acid. That's how chlorine behaves when it is dissolved in water. Now, this solution turns blue litmus paper red. Why does it turn blue litmus paper red? Because there is hydrochloric acid, and all acids turn blue litmus paper red, and then bleaches it. To bleach the blue litmus paper, it means the red litmus paper loses its color and it turns to what? To white. The bleaching action is due to presence of hypochlorous acid. So the hydrochloric acid turns the blue litmus paper to red, and the hypochlorous acid bleaches the red litmus paper, or makes it lose its what? Its color. But we shall look at the details of this when we start chlorine and its compounds, and that will be in senior 3. So for now, I only want you to know the reaction of chlorine with water. Know that it forms two acids, that is hypochlorous acid and hydrochloric acid. This is very important. We now go to reaction with alkalis. Since a solution of chlorine has hydrochloric acid, it means that chlorine is acidic. Chlorine solution is acidic because it contains hydrochloric acid. And since it is acidic, then it reacts with sodium hydroxide. When chlorine reacts with sodium hydroxide, it is absorbed by sodium hydroxide, forming a pale yellow solution. And the pale yellow solution is here, is sodium hypochlorite. This is the formula for sodium hypochlorite here. And sodium chloride plus water. But the condition here is that sodium hydroxide must be dilute and cold. Sodium hydroxide must be dilute and cold. Okay? When sodium hydroxide reacts with water, when chlorine reacts with sodium hydroxide in cold, when sodium hydroxide is cold and dilute, the product is sodium chloride, sodium hypochlorite, and water. So write that condition. This is only possible when sodium hydroxide is cold and dilute. However, when sodium hydroxide is hot and concentrated, then the product is sodium chloride, sodium chlorate. This formula is wrong. It should be sodium ClO3. This O should be after chlorine to make it sodium chlorate. Sodium chlorate plus water. So reaction with metals, sodium, we looked at this, sodium plus chlorine, that's the one we looked at. Then displacement reaction of halogens, we said as you go down the group, reactivity decreases. So it means chlorine is more reactive than bromine. Chlorine is more reactive than what? Bromine. So when a solution of, when chlorine gas is passed through solution of potassium bromide, then chlorine will displace bromine from its solution. Chlorine will displace bromine from its solution and will now form potassium bromide plus bromine. So chlorine displaces bromine from its solution. And since bromine, we said that it is bromine, actually bromine gas is red in color. So a red solution will be formed. If it is a solution, for example, when there is water here, then bromine aqueous, its color is reddish brown. So chlorine can also displace iodine from its reaction, and you'll form potassium chloride plus what? Plus iodine. Because chlorine is more reactive than what? Than iodine. So it will displace it from the solution of potassium bromide. You remember what we said about displacement reactions. Then in noble gases, these are gases which are in group 8, and for them they are stable so they don't react because they have 8 electrons in the outermost energy level, and we say their outermost energy level is completely filled with what? With electrons. That's the reason why they don't react. Their outermost energy level is fully filled with electrons. That's why they don't react. Or they have 8 electrons in the outermost energy level. Let's end here. Please ask questions in my inbox. Send me questions in my inbox. I will welcome them. I wish you a good day. God bless you. Oramangu muntamire. Muramanya ngu naba ndi kukora hanuya abo ndi kugamba nabo ebi muramuragamba barabihurira.